Alright, welcome you guys. Today we'll be talking about graphing other trigonometric functions. So we're going to spend it almost exclusively in Desmos. So one second. Alright, so here is the most famous one. Let me set up the steps. Apparently it forgets every time. There we go. Alright, so here's the most famous other trig ratio. So far we've talked about cosine, sine. They kind of look like a double helix if you turn your head on the side. Now tangent is going to be a little bit different. Let's make it a little bit darker. Let's go red. There we go. Okay, so tangent is going to look like it's going to kind of look like a cubic function. Alright, but it's going to be repeating in pattern because it stops every time. Now, real fast, if we go to draw asymptotes at pi halves every time, you'll find out that it will be an asymptote. So we're not talking about just any old pi halves, we're talking about every odd pi halves. There's an asymptote for tangent. Now tangent's range it's infinite, it goes in both directions, but its domain is every number except for every odd pi half. Okay, now if I change the a in front, that just changes the stretching abilities of it. B, once again, it compresses it, it makes the frequency happen much more. H will move it, give it the illusion of all moving left. This is kind of cool, it looks like an old-timey picture from back in the day. Alright, and K obviously moves it up and down, you know, that type of thing. Okay, now the formula is still amplitude. Well, amplitude is not going to be used as much because we're not dealing with wave height. Vertical shift is still going to be there. Period is going to be tangent. It's going to be pi divided by b. So whatever number b is, it's going to be period. It's going to be divided by pi. And if you notice, from negative pi halves to pi halves, I've completed one complete cycle of trig. Of tangent trig. Okay, alright, so that's why we're dividing by pi. Whereas if I did cosine or sine, it would be between two. It would be a length of 2 pi. So that's why I divide sine cosine by 2 pi. Okay. Alright. Phase shift still negative h divided by b. You know, it just works the same way. Range. Range, highest to lowest, that type of thing. So, okay, so that's it for that. Now the other trig functions too. Remember cosine or cosecant. Let's make that a little darker. Yeah, there we go. Okay, cosecant and secant, they're inverse of each other, and this is how they graph. So I highly recommend, if you had to graph by hand, graph cosine first of the same exact values, and then graph secant as the parabolas coming off of that. Now secant, their vertical asymptotes are going to be at every odd pi halves, just like tangent. Okay. All right. Now for sine, obviously the reciprocal is cosecant. Geez Louise, that's some dark ones right there. Okay, so cosecant. Now its vertical asymptotes is going to be every pi. Okay, and as you can see, it just lines up just to be just like this. Okay, alright, so if you have to graph cosecant by hand, graph sine first, and then graph the parabolas coming off of that, minding the vertical asymptotes. Okay, now tangent we just talked about. It's not gonna, if you notice, it's gonna be a little bit more difficult. Okay, so I always tell my students this. Okay, cotangent is as if we shifted to the right pi half units and then flipped it about on a y-axis type of thing. So it's almost like you're flipping it and then shifting it over pi halves. You know, it depends on which way you want to go. You could go from this 0 to this negative pi halves, or you can go from negative pi to pi halves. It's up to you. But basically those are the two that we're just talking about. Well, there's no way to really graph cotangent on top of tangent because it's not like these other ones where you have sine and then it just looks like, oh, that's really cool. But tangent is just, if you were to shift everything over to the left or right and then flip it about the vertical axis, you would see a nice little shape. And as you can see, it makes a nice little pattern when you graph them on top of each other. So that's the really cool thing. All right, now other than that, secant, cosecant, and cotangent still obey all the same rules, except cotangent's period is going to be pi divided by b. Cosecant and secant, their period is going to be 2 pi divided by b. That's it for graphs of other trig functions. I'll talk to you later.